My name is Stephen Wu, and today we're going over binary search. Binary search is an efficient algorithm for finding an item in a sorted array. It works by dividing a portion of the list in half repeatedly until we have narrowed down the possible locations to just one. Let's look at an example. Suppose we're given this array, ranging from -2 to 13. Remember that binary search only works if the given array is in a sorted order. Next, we have the target 11, in which it is the number that we're looking for in the given array. And suppose we're writing and implementing this function, binary search, given the array and the target as the parameter, and a return value of a boolean of true if the target exists in this array, or a boolean value of false if the target does not exist in the array. So here we have the same example of the given array ranging from -2 to 13. So the first step of binary search is that we introduce two variables. One left pointer at the beginning of the array at index 0, let's call it L, and one right pointer at the end of the array, which in this case is index 7. So the next step will be to find the midpoint between left and right pointer. In this case, our midpoint will be at index 3. And we found out by adding the index at left pointer, which is 0, plus the index at right pointer, which is 7, integer divided by 2, which we get index 3. Now we have the midpoint at index 3. We need to compare. If array at midpoint, which is array at index 3, equal to our target, which is 11, if they match, then we have found our target, then we return true. In this case, it is not. So, because 11 is strictly greater than 7, we know that our target must lie in between the range of index 4 and index 7. Therefore, we can move our left pointer to midpoint plus 1. But let's say our target is 4. Then since 4 is less than the midpoint, which is 7, then we move our right pointer to midpoint. Then we continue the search in this portion of the array. Let's get back to the example. Since 11 is strictly greater than array at midpoint, so we can move our left pointer to midpoint plus 1. Now, we're going to continue the same process until either our midpoint, array at midpoint, is equal to our target, in which case we have found our target, or our left pointer is greater than our right pointer, in which case the target does not exist in the array. So now, since our left pointer is still less than our right pointer, we need to calculate the midpoint again. In this case, our midpoint would be at index 5. Now we compare. If array at midpoint at index 5 equal to our target, then return true. But in this case, 11 is not 9. And we know that 11 is strictly greater than 9, so we know that our target must lie in the range of index 6 and index 7. Therefore, we can move our left pointer to midpoint plus 1. Since our left pointer is still less than our right pointer, we can continue the algorithm. Now we need to find the midpoint again. In this case, our midpoint is at index 6. Now we compare. If array at midpoint, which is 11, if it is equal to our target, then return true. In this case, we have found our target, Therefore, we return true for the algorithm.